Good afternoon. I want to thank everybody for joining us for this presentation today. We're going to show you some new and exciting equipment from Endress & Hauser, and I have the good fortune of actually getting two of the top-notch people at Endress & Hauser to join us today. Today I'm going to introduce first Alan Vance. Alan is the industry manager for the water wastewater, so he is a key figure working with me to help promote the water wastewater products. Alan, how are you doing today?
I'm doing good, Bruce. Thank you for having me, and welcome everybody. Again, my name is Alan Vance, and I am the Industry Marketing Manager for Water Wastewater at Endress & Hauser. I do live in the Tampa Bay, Florida area, and of course, I guess all of us are working remotely with the current COVID situation going on. And really, on behalf of everyone at E&H, we do appreciate everyone taking their time out to listen to this presentation today. One of our flow product managers, Mr. Adam Booth, will be actually giving the presentation today. I may interject a little bit, and then we will be happy to answer any or all of your questions at the end of the presentation. So, Adam, are you here?
Yes, Alan, thank you. And again, I want to echo a big thank you to Vector Controls and Automation Group for hosting us, and an even bigger thank you to all of you who have joined. So my name is Adam Booth. I'm a flow product manager for Endress & Hauser, and I am out of our Greenwood, Indiana headquarters, which is just a little south of Indianapolis, Indiana. With that, we'll go ahead and get started. So for Endress & Hauser, we do have a complete product offering for the water and wastewater industry. So today we will be focusing specifically on flow, but as you can see, we also do have level, pressure, temperature, liquid analysis, data acquisition, and sampling. This is to give you an overview of our headquarters in Greenwood, Indiana. So in the past 6 to 7 years, Endress & Hauser has invested roughly $175 million into our campus in the USA. So it consists of our sales and marketing team, our customer center, and certain technical support and repair support. But we also do have our own flow manufacturing, level and pressure manufacturing, and temperature manufacturing all on the campus in Greenwood. We also do have our analytical manufacturing facilities in California. So let's dive right in. So if you were to take a look at these two installation pictures of these electromagnetic flow meters, you might be thinking to yourself that those look like very poor applications. They are complete 180 from typical straight run requirements that are typically required with conventional electromagnetic flow meters. So as you can see in these two pictures, we have a T-fitting in the left picture directly upstream of an electromagnetic flow meter. And then in the picture on the right, you can see the electromagnetic flow meter installed with directly on the outlet and inlet of two elbows, which, as I'm sure you guys are aware, that is a big no-no when it comes to installations of electromagnetic flow meters. So again, traditional electromagnetic flow meters have required inlet and outlet run requirements. So typically, you will see that the upstream run requirement is 5 times the pipe diameter or nominal diameter of the pipe. And it doesn't matter if it is a pump, a valve, an elbow, or a T-fitting. And then on the outlet side, you will typically see at least 2 pipe diameters downstream requirement. And if you look at the diagrams on the bottom, you can see that we are pointing out laminar flow and turbulent flow. So with electromagnetic flow meters, we definitely want to be on the left-hand side with laminar flow, which gives uniform velocity, resulting in a consistent flow profile. And on the right-hand side is turbulent flow. So if we have any sort of obstruction upstream or downstream, sorry, one second, it appears we're having some technical difficulties. Nikki, are you able to hear me now?
Yes, you are back.
I
Okay,
can
can
hear
hear
you.
you.
How much did we miss?
Right when you went,
Just on a
right when you
turbulent
went to
flow.
this slide.
Okay, I apologize for the difficulties there. Hopefully you all can hear me clearly now. So as I was saying, typically with electromagnetic flow meters, they will have a 5 pipe diameters upstream inlet requirement for any sort of obstruction. So that can be an elbow, a pump, or a valve, or even a T-fitting. And then on the downstream side, you'll typically see 2 times the pipe diameter. So with electromagnetic flow meters, we like to be in the laminar flow, as you'll see on the left-hand side, and that provides a uniform velocity and a consistent flow profile. Once we start introducing some of these obstructions, we start to have swirl, which can result in a turbulent flow, which then results in an uneven flow profile. And so if we have an uneven flow profile, at the end of the day, that affects our measurement uncertainty of the device. In talking about swirl, here's just a 3D image of what the flow velocity looks like inside of a pipe as it travels through an elbow and on the outlet. So you'll see the darker colors, that is the velocity. So you can see how the faster velocity is actually traveling, coming out on top of the pipe as it exits the elbow, and you can see the amount of swirl. So this new sensor option for our ProMag W can provide reliable measurement independent of a poor flow profile. And there are a couple ways we achieve this, and let's get into it. So if we take a look at those inlet run and outlet run piping requirements that I showed earlier, this is just to provide an example of what that actually means to you. So in the first bullet point there, you can see if we have a 10-inch electromagnetic flow meter, on the upstream side, we typically require 5 pipe diameters upstream, which is roughly the equivalent of 4 feet. And on the downstream, we have 2 times the pipe diameter, which is roughly 1.5 feet, so that equals 6 feet of extra piping needed to fulfill the typical inlet outlet run requirements. And then you can see we also show it for a 24-inch line size and then a 48-inch line size respectively. So if we're able to eliminate all this extra piping, what does that do? That means that you can expand your capabilities without having to increase the overall footprint of the plant itself and the piping itself, while maintaining a standard 0.5% measuring uncertainty by installing our new ProMag W 0DN unrestricted option. And also with newer installations, then you can also have a reduction in your piping cost, your installation cost. That also could include a crane depending on the line size. And this also means that you can design your vaults to be even smaller than they are now. And if you are using any sort of skid, it can also reduce the overall size of the skid with the smaller footprint, with the need for less piping. And here are some real life pictures. So, we talked about, a 10-inch and a 24-inch, but now think about it if we start looking at a 72-inch meter, which is pictured on the left, or even a 108-inch meter, which you can see there on the right. So again, think about all the extra piping that's needed just to achieve the standard 5 diameters upstream and 2 diameters downstream. So here's our solution. So you might notice a couple things being pointed out. I want to start here on the top. So a typical electromagnetic flow meter has 1 pair of measuring electrodes, or 2 measuring electrodes in total. So now with this new option, we go up to a maximum of 6 measuring electrodes, or 3 pairs. As you can see, it's dependent on the line size. So from 1 inch to 2.5 inches, you will have 2 measuring electrode pairs, or 4 electrodes, and greater than 3 inches, you'll have a total of 6 electrodes. Now, in the picture on the right, you might notice an electrode on the bottom of the sensor. That is our reference ground electrode, and that is standard on all of our electromagnetic flow meters. And you can't see it in this picture, but we also have an electrode at the 12 o'clock position if you're looking at the face of a clock, and that is what we call our empty pipe detection electrode. So if you have entrained air in the line, or if your line is not completely full, our electromagnetic flow meter will be able to notify you of that. So we do have the multiple measuring electrodes, but we also have a completely new coil design, creating an enhanced electromagnetic field. And along with the mechanical differences, we also have some new changes in the transmitter to include some advanced signal processing from all these extra signals we're now able to measure from the flow profile. This is just to give you some more pictures of some typical installations that you'll see with this new sensor design. So you can see that we can install it after elbows, insertion devices, misaligned seals, T-fittings, any sort of buildup in the pipe that can cause a restriction and affect the flow profile. And you can even install it directly after a 100% valve that's 100% completely open, such as a butterfly or gate valve. And in the top right hand, you'll see pictures of actual testing that we did during development right next to a butterfly valve. So here are the cornerstones and a few specifications for this completely new sensor design. So in terms of the flanges, it will be available with fully welded or freely rotating lap joint flanges. It will be offered from 1 inch all the way up to line sizes of 120 inches. All of our liner materials will be available, and those include polyurethane, hard rubber, and PTFE, or commonly known as Teflon, up to 12 inch. And you can see that it's able to be paired with all of our ProLine transmitters, the 300, 400, or 500, depending on certain requirements, such as if you want an integral mount transmitter, remote mount, and what sort of communications you want. And obviously the inlet outlet run, you can see right there listed that it is 0. And we've already covered how we achieve that. And so our stated accuracy and uncertainty for this device is 0.5%, and that is with the 0 inlet outlet runs. So in the installation shown in the picture, that is a stated accuracy of 0.5% of rate. So you've heard about how we achieved it and some testing we did, but another piece that we always do with our devices is make sure they are verified by a third party. And the third party that Anderson-Hauser uses is TUV, or TUV, as it's ratherly known. So you can see that it was tested at an external and independent accredited test center, and we did achieve our expected and stated performance. So there in the diagram with the chart, you can see that we had this meter installed directly downstream of a T-fitting, and all of our measurement points at all those velocities was well within our stated accuracy. So I mentioned some of the obstructions that we can now overcome, and this is just to give you a picture of what those would look like. So we mentioned the bends, we talked about insertion devices, we talked about buildup as well. So again, if we do have buildup in the pipe, that's going to increase the velocity and it's going to affect the flow profile and create swirl. And then also, if you do have a internal or nominal diameter difference between the meter and the mating pipe, or just in the pipe in general, you can also install it directly downstream or upstream of that change in diameter. We mentioned the T-fittings and also even misaligned sealings. So that was a quick overview of the sensor itself and our new feature. I now want to go over a couple different key points with our complete electromagnetic portfolio. So what you'll see here is this is an ISO standard. So it's ISO 12944-2, and it covers corrosion protection of steel by the use of protective painting or coating systems. So you'll see in the table, there's a list of different protection classes ranging from C1 to C5. And you'll see it starts very low. And then at the very bottom, the C5, I, and M, those are the most stringent for the harshest environments. So you'll notice that for an indoor environment, it's very high condensation, permanent condensation, and very high pollution. And being outside in the environment, it would be very humid or even a saline seaside atmosphere that with some metals would not be able to last. So on our electromagnetic flow meters, we have an option to have a special coating that fulfills ISO 12942 C5I and C5M, which is the highest level of that corrosion protection class that no one else can offer you. And along with this ISO standard, you can see that we also cover the immersion standards, which are fresh water, which is your standard water, sea or saline water, and then the IM3, which is for permanent submersion under the ground. So our coating, again, covers all of these protection classes for immersion per those ISO standards. And the last piece that I want to touch on is going to be on our submergence ratings. So I'm sure many of you are familiar with IP67, IP68, NEMA 6P ratings. So with this new sensor design and our existing electromagnetic portfolio, we have a few different options depending on the application. So you'll see we do have a NEMA 6 or IP67 rating. So what that means is that is more of an accidental submergence. So you can see that it can be submerged at a depth of less than 10 feet for 168 hours or less than 33 feet for 48 hours. And then moving into permanent submergence. So this is submergence underwater. We have an IP68 option. So again, that's going to be that less than 10 feet permanently or less than 33 feet for 48 hours. And then our most advanced option and the most robust option is for direct burial underground under a lake or something else like a vault or a pit. So this is again IP68 rated, but it also has, and you can see it in the picture in the bottom right hand corner, it has that special coating that I just talked about per those ISO standards. So again, it has the same IP68 limitations, but it can also be buried now at a depth of less than 10 feet permanently. So again, we cover the full range starting from an accidental submergence to a permanent burial submergence underground. And then we do have heartbeat technology. So what heartbeat technology is it consists of a self-onboard verification that is traceable to ISO standards and verified by a third party. I'll get into a few more details here in a minute, but we'll touch on heartbeat technology. And then we just talked about this new sensor design. And then also with our electromagnetic portfolio and our other flow products, even some of our analytical products, we do have Ethernet IP as a standard output option with all the software and hardware needed for integration into a Rockwell control system. So heartbeat diagnostics, these are standard diagnostics that are running 24/7 around the clock. And you can see that we have our diagnostics designed to an AMOR NE107 standard. So you can see some of those icons, and if you think about it like the dash on your car, telling you when your battery's low or your fuel's low, or you need to check your tire pressure. Our meter display, and also if you're communicating via digital signal through a control system, it'll notify you if you are if the device is okay. It'll give you a yellow triangle if something is out of specification, and it will give you, a red failure if there's a critical failure in the device. And the other cool thing about our diagnostics is they also provide remedy information. So for example, if it's telling you that your output is out of range, it'll actually pop up on the screen and tell you to check your output settings or check your process. And it might also let you know that you could have coding happening on the electrodes. So it does give you that remedy information instead of having to go dig through a manual and find the diagnostic code, which can take time. So that was the diagnostics piece. The piece I really want to focus on is the verification. So heartbeat verification, as mentioned earlier, is an onboard self-verification that you can run on demand without any process upset or process impact. So as you can see, here's an example of a verification report. So as soon as you run that verification and it completes, you are then able to pull a PDF report of the verification, and as it's going to be showing you all of the tests that were ran, and then if the meter passed or failed. So it's sending a test signal starting at the sensor, it's checking the coils, the electrodes, and it's then going to verify the transmitter and all the electronics. And what's really cool about this is that it will also do a loop check on your current outputs, your 4 to 20 milliamp outputs, or even your pulse output. It'll verify that it's functioning. And this verification itself, it's a tested by a third-party TUV, similar to the testing we did on the new zero inlet outlet run meter. It has redundant references. So electromagnetic flow meters, the principle is around voltage. So we have a redundant voltage reference built in that's calibrated while the meter's manufactured and calibrated at the factory. So it's ISO 9001 traceable. And that's the other piece there that's really cool about this onboard verification. And lastly, just to cover some new things with Endress and Hauser. So we now have our interest.com. So this is really to simplify and you're able to personalize your online digital experience with us. So you're able to create an account on our website for free. You're able to do any quoting and purchasing needs. You can even get CAD drawings, so 2D and 3D CAD drawings. You can get them through your portal. You can also ask for technical support or any assistance, and all your manuals can be stored in there. And that also includes all of your transaction history and your delivery tracking. And I'm not going to read through this whole list, but just a summary of everything you can do on our interest.com portal. So if you haven't heard of this, or if this is something that interests you, please reach out to Vector Controls and Automation Group, and they can help you get set up with an account and walk you through it. There's a lot of really cool features in here, but I just don't have the time to go over each of them. And lastly, this is a quick snapshot of Vector Controls and Automations Group territory, and you can see Bruce Philpy's contact information there. So do not hesitate to reach out to him with any questions. And with that, that'll conclude my portion. So Nikki, I think we're okay to open it up for questions now.
Great, thank you so much, Adam. And we do actually have a few questions from our audience. First question, do these require ground rings when installed on non-conductive pipe?
Yes, thank you, Nikki. So yes, with this new sensor option, you still will need grounding rings or grounding discs dependent on the pipe material. So if you're going to be installed in a PVC or composite material pipe that is not grounded, you will still want to install with grounding discs and run that back to a protective earth ground. Great question.
Yep.
Okay, next question. Does Vector offer any on-site service?
I'll catch that one, Adam. Yes, we have a trained staff to be able to come on site and help people. Great question.
Okay, wonderful. Next question. Was it tested against H2S? Oh, I'm sorry. Sorry, I apologize. My screen moved on me. Was it tested against H2S gas level?
So that is a great question. I don't believe we specifically tested this new option against the, the amount of H2S that we'd be able to handle. But as mentioned, we do offer a wide variety of electrode materials and liner materials.
Let me jump on
Yeah,
with you.
Adam.
The
I think I
coating
can interject
on
too.
the outside is a pretty dense coating, so the external meter itself will be pretty impervious to attack by H2S.
Yeah, Bruce, I was going to comment on that as well, is that really the change that we're discussing today is the new additional electrodes in the mag. The external coatings and the submersion ratings, we have had those for many, many years, and we've installed these in very, very difficult applications like lift stations, headworks, etc. So our coatings do hold up to various gases like H2S.
Okay, thank you. Next question. Does E&H offer any non-software method for meter calibration and verifications after they are being installed?
Yes, so I'll take that one,
Yes.
Nick. If I'm understanding the question correctly, so we need to make sure we differentiate between calibration and verification. So the heartbeat technology that I mentioned, that is an onboard self-verification. So no extra special software is needed to perform that verification. It is built into the meter, and all of our electromagnetic flow meters have a built-in web server. So when your meter is delivered, it'll be delivered with an Ethernet port built into the meter, and you can take a standard Ethernet cable in your laptop without any extra software, hook up to the meter, access the web server, and run that verification. And if you don't want to have to physically hook up, we do have a wireless LAN option, so you can connect to the meter's web server remotely with a phone, tablet, laptop, run that verification, and pull that PDF report.
Hey, Adam, Alan, just to build on that as well, you can run a verification from the faceplate of our electronics. As Adam mentioned, we have an Ethernet port and a built-in web server as well, and that can be either physically connected or with the WLAN. And then the third way is if you have all your flow meters on a plant-wide Ethernet network, or you can actually run the verification from the control room. And it only takes anywhere from, say, 30 seconds to maybe 5 or 6 minutes based upon the size of the meter. We do show this at WEFTEC every year, and we do have small meters there, and the verification is very simply done and done very quickly.
Let me jump on here too. If you're looking for a secondary proof of actual flow, E&H does offer a clamp-on flow meter that we can apply to the line, but now we're going to start talking about piping and how critical piping is. But if you're looking for an independent, hey, is it really flowing that amount? E&H does offer those choices as well.
Okay, great. Next question. How does the price point compare to the traditional models?
I think I can answer that one as well. This is Alan. You know, I've been doing mags for a long time, decades, and you know, we understand the municipal market, the specmanship, the integrators, the multiple bids, et cetera, and of course the pricing plays a role in that as well. So we were pretty effective from a marketing standpoint to price this meter right in line with our current standard 2 electrode design that we've been selling for many, many years. So I believe it's less than 5% total. So this particular option with the multiple electrodes is almost right in line with our current mag offering and current pricing, which is very competitive in the marketplace against most of the major suppliers. So it's not like this thing is 20, 30, 40% higher than its traditional mag.
Okay, great. Next question. Will you explain the difference different test bench piping and flow velocity arrangements during the TUV testing?
Yeah, so this is Adam. I can take that one. So maybe something, Nikki, another document that maybe we can share with all the participants after this webinar. We do have a complete data set for that testing that was completed. So it shows the velocities and the uncertainties and all the piping arrangements. So if possible, I'd like to be able to share that instead of taking the time to go through it now, if that's acceptable.
That sounds great. And for certain, the person, Michael, that asked it, Michael, we'll get you a copy of that, definitely, this document. So next question, is there any longer lead times for these versus the standard meters?
Alan, do you want to take that one?
Yeah. Yes. We currently, now, of course, we're under the COVID situation, which has impacted us a little bit. Our factories are still working. E&H is still open for business. But we anticipate this new mag with the multiple electrodes to be in the same delivery profile as all our other magnetic flow meters. So we're probably looking at anywhere from 10 to 20 some working days. Now, that's probably through meters up through, I'm going to say, probably 24-inch. As you get into the bigger meters, obviously we manufacture those, but they do take a little longer. But every time we quote a particular job, project, or one mag meter to a customer, it will have the delivery time on the quote. But our goal is to bring this all into our standard delivery when we're not battling with COVID and stuff that we get from our suppliers, et cetera.
Okay, thank you. Next question. On a submerged mag, do you have to use an epoxy to seal the unit?
Yeah, so I can take that one. This is Adam.
Yeah.
That is a great question. So I showed you the different offerings we had depending on if you needed accidental or permanent submergence. And with those options, you have two different selections. You can choose to pot it yourself, and so the meter will be delivered unpotted, but it will include our potting kit with instructions. And so then you would pot it yourself, or you can have it be potted at the factory. So you can just install it and not have to do any extra work.
Let me jump on with you on that one, Adam. This is Bruce. What they do when they go to a submersion system is if you were to look inside the shell, a normal NEMA 4X unit doesn't have any additional filling on the inside of that shell. When they go to a submersion unit, they actually fill that inner shell with some additional compound to make sure that if water somehow, some way were to get through, it won't still get to the electronic parts that's inside that shell.
Mm-hmm. Yes, I would add to that you know, when we go to the IP68, our sensor is fully welded, and again, as Adam mentioned, we have the two customer potting and factory potting. I'm a little bit old school. I would err on the side of factory potting, and just make sure you order enough cable length because you don't want to have to dig out all the potting material to redo a cable. But that way it'll come complete from the factory, fully potted, and then you'll have 30 or 50 or 75 feet of cable, whatever you want, and you just hook up and go. But we certainly do have both those potting options available.
Okay, next question. Has anyone ever actually buried a meter?
Oh yes, over the years I've seen many mag meters buried in the ground. I happen to live in Florida here. We don't bury them that deep, but you know, in years past, you'd have to basically denso tape. It's kind of looks like saran wrap almost around the whole meter. And while it did work, it was kind of a pain in the neck to do. So our new custom coating, that gray colored coating that Adam showed you on the picture, boy, if you're putting it direct burial, I would get that gray coating on there. and you can mount the mag right underground, and then you can put all the backfill right over top of it. Not a problem.
Okay, next question. Are there any cases where not to use this meter, like after certain fitting pumps, etc.?
Yeah, that's a great question. So as you saw, we specified it for tees, insertion devices, changes in pipe diameter, and then we did the testing on valving with the valves being 100% open. So we did also perform testing on pumps. We're still in the final stages of wrapping up the testing and putting it in a report that we can share with our customers. So I don't have any information today on the specifics of the pumps or what types of pumps, but you will see that become available here shortly.
Yeah, Adam, I think I can shed some light on that as well. Adam did mention pumps, but as far as control valves, such as a positioning control valve, we did check, and that would still require 2 pipe diameters upstream of the meter if it is a positioning control valve that could be 10, 20, 30, 80% open or closed. So the butterfly valve and a gate valve we mentioned, that's if it's fully open, 100%. We have no problems with maintaining a 0.5% accuracy.
Okay, do you offer battery powered models with field replacement batteries?
That must be an E&H person asking that question, I think. The answer is yes, we will. The problem is that we don't have it right now. We are introducing in Q1 of next year, January, we will have a W800, which will be a battery powered mag meter. And I believe, I'm not sure what size it'll go up to, Adam. Maybe you know that off the top of your head?
Yeah, so yeah, we currently do have a battery mag offering. As Alan mentioned, we are in the midst of developing a new offering for a battery electromagnetic flow meter. It will be available in larger line sizes. I think you would be seeing maybe from 1 inch up to roughly 24 inches, I believe.
Right.
But you will see that battery mag will also have this option for the multiple electrodes.
Right. I meant to say, I said that wrong, that it'll be available in bigger sizes. And it will be this existing W sensor. So one marketing thing that turned out very nicely for us is that we did not develop a whole new sensor. The multiple electrode mag meter sensors that we put in there is into our existing mag meter. And when we come out with the new 800 series battery mag, it'll be the same sensing tube as well. So the lay lengths will be standard, et cetera. The options will be standard. It's just that there'll be a difference up in the electronics, whether it's powered or battery.
Okay, great. Next question. Can we use these in sludge metering?
Yes. We have many different styles of mag meters. Currently, we have our standard W series. We have a great mag meter that's a 55S that we use on a lot of sludge applications. But I believe this meter here will also be able to use on sludge applications as well.
Okay, great. Next question. Does the meter communicate over Modbus TCP as well?
So currently, our electromagnetic flow meter has HART, Ethernet IP, Profibus PA and DP, and Foundation Field Bus, and Modbus RS485. So Modbus TCP IP is currently not available on our portfolio, but it's something that we're definitely looking into.
Okay, next question. We have a few minutes left and a few questions, so I'm going to try and get through all of these. How long Have these been deployed in the field, and what is the track record?
Great question.
Yeah, I can interject on that. We showed this unit last West Tech, which was in Chicago in October, and then we released it in its entirety to the world, including the US, in January. So we've already sold, I haven't checked lately, but I think we've sold in the US already probably close to 30 or 40 of these just in the first quarter. So we are, building up a customer list, and we will have pictures of installations, feedback from customers, etc. But generally speaking, E&H is one of the world's largest suppliers of mag meters. So we have just millions of our mag meters throughout the whole world. And of course, the U.S. is a very big market for water wastewater. So we have many accounts throughout the 50 states that use our flow meters.
Okay, thank you. Next question. What is the performance when discharging into a T or a larger diameter pipe, or vice versa?
I'll take that one, Nikki. If I understand the question correctly, I think you're talking about on the outlet side, and then if it's discharging into, a larger pipe or into a vault or something like that, or a pit. So you would still be achieving that 0.5% accuracy as long as the meter stays completely full. That is the key to remember there, is that the meter always needs to stay completely full of water.
Yes, and to add to that, full pipe is key, which is why we do like vertical installations with flow going upward, but these work very well on horizontal pipe runs. And the fluid conductivity does play a role. We don't have to worry about too much of that in water wastewater, because that's typically very conductive. But if you have some very, very low conductivity processes, that we'd have to look at that a little closer. But I believe once it goes past our electrodes and it discharges on the other side, typically is not a problem for us.
Okay, thank you. Next question. Does the small mag meter support POE?
I think I can answer that one. We have Ethernet IP on our 4-wire devices. So our mag meters, our Coriolis meters, our analytical transmitter, and then we have a data recorder that has Ethernet IP. It has an Ethernet port and web server, etc. We are working closely on power over Ethernet, and specifically for our 2-wire devices. So things like level transmitters, pressure transmitters, and even 2-wire flow meters. Currently, we do not have those. They are in our R&D, and they will be coming out. I don't really have a timeline on it, but it is certainly something that we want to do. I think they have power over Ethernet figured out, but then there's also area classifications that we have to worry about, things like that. So it will be coming down the road, but we do not have it currently available for 2-wire devices.
Okay, next question. Would this type of flow meter reduce the need for a reduced bore flow meter?
I can take that one.
Yeah. Go ahead.
So we currently in our portfolio, we do have a reduced bore electromagnetic flow meter, which can also achieve the no inlet outlet run requirements. But the one thing that's important to pay attention to with the reduced bore versions is that also does create a pressure drop across the meter, and it increases the velocity. So with this new sensor option, we can still achieve the no inlet outlet run requirement, but it's full bore, so there's no pressure loss. Now the reduced bore still has its place. For example, when you're dealing with lower flow rates, you're able to achieve a better accuracy with lower flow rates due to the reducer. So it really all depends on the specific application.
Yeah, I think that's a good point, Adam, because for flow in general, we really never have too much problem with higher flows. These meters can handle up to 33 feet per second, and nobody really ever pumps that quickly. So we are concerned all the time about low flows, because we often get asked, hey, I need a flow meter for a 1-inch line, and then we check all the flow data, and man, they can do that in a 1/4-inch meter. So as Adam stated, the reduced bore does have its fit, and we do have that available as well in this same W sensor family. So based on the application, we look at that, and then we can quote the best meter for your application.
Let me jump on here with you guys as well. The reduced bore meter is really from 1-inch to 12-inch. So once you get above 12-inch, that is no longer available. All we really have to offer is going to be the multi-electrode solution.
Correct, Bruce. Good point.
Okay, next question. Are the 4 or 6 electrodes standard or bullet nose?
Great
So,
question.
yeah, that's a great question. They will be offered as standard or bullet nose. So all of our electrode options are available for this multi-electrode design.
Great.
Okay, and is the new sensor available with the Class 1 Div 2 approval?
It is. It's available with all area classifications. So anywhere from non-hazardous Class 1 Div 2 and even up to Class 1 Div 1 explosion proof.
Can flow be expressed in cubic feet per second and the total in acre per feet? Bruce, do you want to take that one?
I'll grab that one. Yeah, I got a customer who wants that, and the answer is yes. We can do customized totalization units like acre feet.
Wonderful. Next question. What is the sampling rate compared to the standard 2 electrode tubes?
This is Adam. I'll take that one. So the sampling rate is definitely faster. In terms of magnitude, I believe that it's either 5 or 10 times faster than our standard 2 electrode traditional mag.
Okay, and with that, I had one last question, actually a comment saying we are asking really good questions. Give this group some props. And so thank you so much. With that, we did go over a little bit, and I apologize for that, but thank you so much. You've been a wonderful audience, and we hope that it really was worth your time today, and you learned from our experts and have some valuable takeaways. Closing comments, Bruce.
I want to say I appreciate everybody spending a little time today with us. Excellent questions. Look forward to working with you in the field. Just give me a call. My number's there on the screen. So I'm here. Email me. I'll get you taken care of. Thank you.
Yes, this is Alan Vance again. I echo what Bruce just said. I thank everyone for taking their time. You know, I know at E&H we are working hard to develop products for the water wastewater market that have the right form fit for your application. So we will continue to do that, and we think this is a great product that's going to really solve a lot of old traditional headaches that we see when it comes to straight pipe runs. So we appreciate your time. They were very good questions. I'm glad Adam was here because there was a couple of them I'm not sure I could have answered correctly. But thank you, and we look forward to working with everyone. Adam?
Yes, thank you, Alan. So again, I just want to echo what Alan and Bruce said. A big thank you to all of you for joining. Those were very, very good questions. Very impressed, and it seems like you guys were listening, so that's always good. And we will be sure to follow up with some of that further information on that third-party testing. So again, thank you to everyone. Appreciate it.
Okay, great. And if we did not get to your question or we missed it by chance, we will follow up with an email. So again, thank you for joining us and have a great rest of the day.
Thank you. Bye-bye.